Let f of xy equal to x squared y cubed minus 4y. Let the vector function v equal to 2i plus 5j. Find the directional derivative of fxy. The directional derivative is going to be equal to the unit vector of v dotted with the gradient of f. So I'm going to start by finding the unit vector of v. We can do this by taking the magnitude of the vector v and dividing it by itself. So first let's find the magnitude. We can find the magnitude by taking the square root of 2 squared plus 5 squared. This is going to equal to 4 plus 25, or just the square root of 29. So our magnitude is the square root of 29, and we need to divide our vector by the magnitude. So let's rewrite vector v into vector notation 2, 5, and now let's divide by our magnitude length. So this will just be 2 over the square root 29 and 5 over the square root of 29. Now let's find the gradient of f. We can find the gradient of f by taking the partial derivatives with respect to each variable. So the partial derivative of x squared y cubed minus 4y with respect to x is going to leave us with 2x y cubed. And this minus 4y does not have any x value, so it's not included in the derivative. Now let's take the partial derivative of our function f with respects to y. That will leave us with 3x squared y squared minus 4. Now that we have all the information we need, let's take the dot product. The dot product is fairly simple. We just take the first term of our first vector function times the second term of our second vector function, add it to the second term of our first vector function, multiplied by the second term of our second vector function. So we're going to leave off with 2 over the square root of 29 times 2x y cubed plus 5 over the square root of 29 times 3x squared y squared minus 4. We can simplify our expression further to leave us with 1 over the square root of 29 times 4x y cubed plus 1 over square root 29 of 15x squared y squared minus 20. And this is equal to the directional derivative of f of xy.